multiplying fractions is no different than the multiplication of numbers, so long as we look through the lens of a story. If we want to look at 1/2 times 4, remember that this is 1/2 times of 4 objects. So we're looking at 4 objects, 1, 2, 3, 4 objects, but instead of this where I have 1 time of 4, I need to look at what 1/2 of this would be. Well, 1/2 of 4 objects, you can look at this a few different ways. You could either break this into 2 different pieces, so that each of these are 1/2 of 4, 1/2 of 4. Or, if you'd like, a creative approach is to take 4 different objects and do 1 halving action to each of them. So we'll take this and break it into a half and claim 1 of them, take this and break it into a half and claim 1 of them, take this into a half and claim 1 of them, and take this into a half and claim 1 of them. Now if we reorganize these pieces, what we will get is 4 different pieces that are 1/2 large, all claimed, and 4 different pieces that are unclaimed, which is really the same thing as 2 whole pieces claimed and 2 whole pieces that are not. So either way, you're going to see that 1/2 of 4 is either an action or a repetition. Essentially, it's the same thing as saying 4 divided by 2. And this gives us insight into how we can relate these different numbers together. 1/2 of 4 is the same thing as 4 divided by 2, which is the same thing as 4 halves. Now, what's really interesting is that this idea of fractions tying into division is actually where the division symbol gets its shape. If you look at this division symbol, it has a dot, which represents a number, a line, which represents a fraction bar, and another dot, which represents the other number. So in a division equation, you can see that the 4 should go along with the first dot, and the 2 should go along with the bottom dot. It's part of the symbology. It helps us keep track of what's the meaning of this phrase. So 1/2 of 4 can be thought of as 4 divided by 2, or 1/2 of 4 objects. Let's now look at what 1/2 of 3/4 is. Well, I like to look at this as, again, a brownie tray. So let's take a big brownie tray. Let's first look at it as saying I am going to split up this brownie tray into 4 different pieces, because I'm looking at 1/2 of 3/4 as being the story. 1/2 of 3/4. Well, 3/4 is 3 objects claimed out of a brownie tray that's been split into 4 pieces. And so 1/2 of that is going to be equal to splitting each of these in half and claiming only 1 of them. So we're going to split this in half, and then we're going to remove these. We only get 1 of each of those 2's. So that's 1/2 of 3/4. Now that's one way we can look at it, but as we saw in the last lesson, you can also look at multiplication where you use that commutative property, the ability to move things around. So you could, if you'd like, look at this as 3/4 of 1/2. So let's look at that diagram. We're going to first draw 1/2, which is 1 object split in 2, where we claim only 1. And then 3/4 of that is where we need to look at our claimed object and split it into 4 pieces, and only claim 3 of them. So we have 4 claimed right now. Let's erase the bottom one, and that will give us 3 of 4 pieces. So 3/4 of 1/2, either way you calculate it, is going to be 3 of 8 pieces. So how can we represent this without pictures? Well, we can recognize that this 3 of 8 occurred because in the taking of 1/2 of 3/4, we still had the same amount of shading that was given to us. All we did was made every single shaded region go smaller. So 1/2 of 3/4 was where we still had 3 objects. You can see them down here, 1, 2, and 3. So the 1 of the 3 objects gives us 3 objects in the end, but the size was 1/2 of the 4. We split it into 4 pieces and then split those 4 into 8 pieces. So what we're doing is actually multiplying straight across. And we can verify that when we're looking at 3/4 of 1/2. 3/4 of 1/2 is going to be where I had 3/4 that I was claiming out of 1/2. Well, first I had 1 of 2 pieces, and then when I claimed 3/4 of it, I made it into 3 pieces, but each of those pieces were 1/8 large. So multiplication of fractions can be done with just our numbers, where we multiply straight across. But it's important that we remember why that is true, because if we resort to simply memorizing rules, we're going to find ourselves in a number of different fraction problems where we're confused what's the proper process.